Sure, let's give a proof of the following expression for E as a limit of a product involving primes. Here, pk is the kth prime, pn is the nth prime. This is the product of the first n primes, and then if you take the pnth root of that number and let n go to infinity, you get E. Let me give you some data to show that it does converge, slowly, but it does converge. This is the product of the 10 primes, the first 10 primes, and then take the root by the 10th prime. It's that much. So, and then this is the error to E. So E minus that number is 0.5. So we're about half away. And as we go along, this is 10 primes after 20 primes, etc. And after we go along, then you see that we are getting closer and closer and closer to E. After 1,000 primes, we're at 2.68, so that's 0.03 away from E. So what is the reason for that limit to be E? It comes from the prime number theorem. The prime number theorem tells us that the limit as x goes to infinity of the quotient of the prime counting function divided by x ln x is 1, where pi of x is the number of primes below x. Now, there are other formulations of the prime number theorem that are equivalent to this one. For example, if Pn is the nth prime, then the limit as n goes to infinity of Pn divided by n log n is 1. This tells you that the rough size of the nth prime is n log n. Now, that's still not the formulation I want. I want another equivalent formulation for the prime number theorem, which is the following. This is called the Chebyshev, the first Chebyshev function, and it's the sum of log p for primes less or equal to x. And the prime number theorem is equivalent to the fact that the limit as x goes to infinity of the Chebyshev function divided by x is 1. Now, if I put x to be the nth prime, then I'm adding all the primes up to the nth prime, and then divide by the nth prime, and that limit has to go to 1. So that tells me that the limit as n goes to infinity of the sum of the logarithms of the first n primes divided by the nth prime, that limit has to be 1. So why is this true? By taking natural logarithms, this is equivalent to 1 is equal to the limit as n goes to infinity of the logarithm of that expression involving primes. But now, using the properties of logarithms, this exponent can come down multiplying, and the logarithm of a product is the sum of the logarithms, so this expression is equivalent to 1 is the limit as n goes to infinity of the sum of the logarithms of the first n primes divided by the nth prime. But that is precisely equivalent to the prime number theorem by this expression, which is equivalent to the prime number theorem as we saw before.